Welcome to this video on partial fractions decomposition. There are essentially three types. We're going to cover what I call type 1 here, where you have linear denominators. More on that later. What we want to do here is decompose this into fraction plus fraction. The best way to do that is to start by factoring your denominator so that you can see what your denominators will be once we split this up into two fractions. So create a fraction with each of the denominators. And in the numerator, just pick any random letter you want. I just randomly picked T and S for no apparent reason. My goal now is to find out what values of T and S would make the two expressions equivalent to each other, meaning equal for all values of X. So what you want to do here is start by combining these into a single fraction. That's going to help us find out what T and S ultimately equal. But I can't add fractions if the denominators don't match. So to get them to match, I will use the multiply by 1 trick. You'll notice the blue thing is a 1 and the orange thing is a 1. And by choosing these two 1s, I now have a common denominator and I can proceed to condense this into a single fraction. So I'm going to distribute the T and distribute the S. And now that I have a common denominator, I can add the numerators together. Now notice I slightly rearranged the order of the terms in the numerator. That's not mandatory, but I did it for my own mental sanity because I wanted to keep my X terms together on the left and my non-X terms together on the right, which will help in a moment as you see here. So in order for all of these fractions to be equivalent, I'm going to have to pick T and S in such a way that T plus S equals -3. Noticing the terms in red, the only way that these could equal each other is if the two coefficients added to -3. And I make an equation that represents that reality. The same thing has to be true for the non-X terms. You'll notice them in green here. The only way all of these expressions can be equivalent is if the two green things are equivalent. So I make an equation out of that as well. And once you've made an equation out of each of the comparisons to the original problem, you then solve that system of equations. The thing at the bottom of your screen is essentially a middle school problem. Now I'm not going to show the work here, but if you did the middle school work, you would end up with these two answers for the two unknowns. Algebra not shown here. Lots of steps happen in between there and there. The point is, however, once you get values of T and S, you can then take the original expression that you broke the fraction into, the original two-fraction expression, and now put those values in for T and S, and you're done with this problem. If you watch the third line here, substituting in the values of T and S, I'm now finished with this problem. Thank you for watching.